So when we have multiple functions and we're trying to take the derivative, that could get confusing because we have different derivative rules for different kinds of functions, correct?
That's because you were gone, right?
Because you were late. Got that back to Mr. Gray. All right. So we are used to doing problems like this. What's the derivative of sine of x? Cosine of x. What if we change the problem to look like this, though? So we kind of have two things going on here. We have the sine function, but we also have the function 3x, because we're putting the function 3x inside there, okay? So I call this an inside and an outside rule. So we really have to then do two things, and then I'll kind of show you the definition. We still do the derivative rule. We still do the cosine of, but now we have to do of 3x. Do you see, because that's what we're taking the sine of? But then we end up multiplying it by 3. Because this is the derivative of the outer function. And this is the derivative of the inside function. Okay, so we call this the outside-inside rule. So notice when I did the derivative of the outer function, how I left it the same, because I was taking the sine of the whole thing 3x. So I'm taking the cosine of the whole 3x, but then I'm taking the derivative of 3x, which is 3. So here's why this works. When you take the derivative of something, you'll see later, if I would say, I'm going to pick a different value, okay? If I said, hey, I have a function u. To take the derivative if it was the sine of u, to take the derivative, what I'm going to do is this. I'm going to take the cosine of u, what's on the inside, but then I'm also going to multiply by what I say is du, and that's the derivative of u. Okay. Let me just show you how it works. You don't have to do this every time, but this is why it works. In this function up here, what is in this spot where the u is? 3x, right? What is the derivative of u then? 3. So if I use substitution then, okay, I have the cosine of 3x times 3. That's where that comes from. Okay. Would you first of all, this is 3/6. 3/6, no. It's 2/4 in the Larson book, that's why it says that. So we're going to use the chain rule to find a derivative. You don't know what it is exactly yet. The only time you're going to use chain rule is when I'm applying a differentiation rule to something other than the variable that I'm differentiating with respect to. So underline that or read it a second. I am saying you need to tell me the derivative with respect to x, right? Which is fine here. But if I say, hey, I want the derivative with respect to x, this is no longer an x, it's a 3x, and so that's why I need to do that. So whenever what you're using your rule is something other than just an x, that's when you're going to use chain rule. Now sometimes, for instance, chain rule, I'm using it, but it ends up not being anything. For instance, if I had the sine of x plus 1, let's think about that. The sine of x plus 1, what's the derivative of x plus 1? Just 1. So in that case, it wouldn't make a difference. All right, so this is why these things do not match. And when those things do not match, I have to use chain rule. Okay, what is the chain rule? This is what I was just talking about before. There's a couple ways that you can think of this, okay? You can rewrite it as a function, meaning your new function would be a separate function. And here is what the chain rule says. Here's how we take the derivative. When I have a function within a function, I have to take the derivative of that function, so I apply that rule, and then I have to multiply it by the derivative of the inner function. Okay, so I'll show you this. I'm going to write down in plain English. Derive f of x, leave g of x alone. That's what you're going to do first. You're going to derive f of x and leave g of x alone. You're going to leave it in there. Then you're going to multiply by the derivative of g of x. So first you're going to derive f of x, leave g of x alone. Then you're going to derive, take the derivative of g of x. So you have to, this is why we did work over the summer of composite functions, to remember that. And you guys did a really nice job with that. Because first step is we're going to have to figure out what's the outer function, what's the inner function. On that last one, the outer function was sine, right? And the inner function was 3x. Does that make sense? Okay. Does anybody need more time to write this down? Okay. Then let's do a couple examples, okay? Example 1. So I'm going to think of this as this is my outer function and my inner function, and you can write this as like the whole u and du thing. For instance, what's the inner function that you see there? 3x squared plus 1, okay? So I'm going to use the u business. If you don't like it, that's fine, copy it down. My outer function is something to the fourth, correct? I have something to the fourth, so I write it as u to the fourth. My inner function is 3x squared plus 1. Eventually, what am I going to need? I'm going to need the derivative. So let's write that down. What's the derivative of 3x squared plus 1? Okay, so these are all the things I need to solve the problem. To take the derivative of u with respect to u, wouldn't I do 4u to the third? But then I have to multiply times the derivative of with respect to u. Okay, let's sub it in. Let's sub it in. How would I write that with these values instead? Four parentheses 3x squared plus 1 to the third. I'm just subbing in u. Do you guys see that? Times du, what is it? Times 6x. Okay. Is there any way that I could simplify that? Yeah. What? Wait, what? That would be a lot of work. Oh, the multiplying out business? Yeah, well, we can just, can't we just do 24x and put it in front? Yeah. 24x, 3x squared plus 1 to the third. That's the first derivative. Now, first derivative. Where it becomes a lot of work is with the second derivative. That's where it becomes a lot of work. Okay, so first, wrap your head around that, please. Do you guys have any questions about where I got anything from? I don't expect you to write this out every time, but I think it's helpful to see what I mean, what I'm doing, so you see that, hey, I'm really, this 4 here came from here, you know? And that 3 is because I decreased it by 1. Notice, did I change the inside at all? I didn't change the inside at all. I did the outer rule first, then times the derivative of that. Okay, so this is for the first derivative. Do you notice in the instructions I ask you to find the second derivative? Wowzers. It might not look so bad at first, but what is really going on here? List all the things you see. Is it this product rule and power rule and chain rule? Those are all the things you're doing. I'm going to draw a line through here.